When I first started working on the development of the helmet, I thought a helmet is just a helmet. It's been like that since Roman times. It can't be that difficult. But I was wrong.
The aim of the new HPS SafeGuard is to fill a gap in the product portfolio by bringing to market, worldwide, a helmet designed for the traditional firefighter customer, wherever they are in the world. And it was particularly important for us that the helmet should succeed in providing an especially high level of wearing comfort. In addition to this, we wanted it to be the lightest helmet on the market, which is something we think we've achieved. And to help with other aspects of wearing comfort, like good weight distribution, for example. But other features are also important, such as having a system-based approach. It needs to be able to work well with different respiratory protection products and concepts. Lighting systems should be integrated. Helmet communication systems need to be integrated to be sure everything works well together.
With this type of project, the market research basically begins right at the start, very early on. Before any engineer starts working on anything, actually. We sound out the customers to establish their needs. We get information about real issues, such as how users handle the helmets, and not just how you put one on, but also how you store them, clean and maintain them, and of course, how they are actually used in operation. This begins right at the start, at the concept stage, where we describe the product we want to ultimately end up with everyone contributing from their point of view and based on their competencies. Discussing what's even technically possible, for example, or what's already on the market. Then we work through the design together to come up with a product specification that meets the demands of the market. And then we set about putting it into practice. This also involves patent research, technical feasibility studies, everything necessary to meet the technical requirements of the cross-functional team.
It's a bit like designing a chair. Just as it's difficult to create a completely new chair, it's just as hard to design an entirely new helmet. And this is made all the more so because of the other design considerations that we have thankfully become aware of in recent years, such as the fact that the helmet must not only be pretty, but must also take account of factors such as anthropology, ergonomics, comfort, and intuitive use, because these are things that really matter, and what we as designers really have to concern ourselves with. It's not just about the design of the helmet itself, the overall shape, and the grand plan. It's really about the details as well, about the interfaces between the user and the product, the various adjustment mechanisms like the fastener for the chin strap, the size adjustment for the different head sizes, and when you look inside. Where can I do some fine adjustment? Where should pictograms be? Where are the pointers to advise me how to assemble and disassemble the helmet? These are all elements we look into and test, and continually refine with users. The helmet is also often the place where the fire service puts its emblem, and where the firefighter's name is displayed, and it is normally found in a prominent position on top of a locker. So I believe it's a key piece of equipment in terms of identification. After the first prototypes, which were foam mock-ups that you could not put on, but which already looked pretty good at first sight and really quite crisp, modern and dynamic, there was naturally a strong urge to be able to actually try on one of these helmets. It was a really incredible aha moment and a great milestone in the project when we actually received the first real prototypes, which by then were painted instead of the first versions that we had left white, the ones that came out of the 3D printer, to which we had added interior fittings, which you could try on and look at yourself in the mirror with. Although the visors still weren't see-through, you could still get a first feel of the size and proportions of the helmet, how it sat on the head, and where a bit of fine-tuning was needed. The places where it was a bit too wide or where the side view needed a bit more streamlining to give it a sportier look. And it truly was a fantastic moment when the tangible, real-life models arrived.
So, when we work with Dräger in the safety division, it's with the main objective of improving the products. Nowadays, we can even attach motion sensors and speed sensors to the products and to a person's body and use those sensors to take measurements everywhere. And using just these patterns of motion, we can generate models of human bodies and show the relationship between the product and the person. We also measure pressure distribution. So, wherever a product puts pressure on the body, we place foil between the two structures and obtain images, which show us if there are any pressure leaks, how high the pressure is overall, how well it is distributed, and whether it is well or poorly cushioned. These are all methods that are of interest from both a technological and a results perspective.
What we also did was to enter the realm of augmented reality. Once we had a helmet design we all agreed on, and once we had created and modelled it in CAD for the first time, we developed an app where practically anyone could use a tablet to hold a mirror in front of their face and see themselves with the helmet on. You could change the colours and raise and lower various fittings, such as lights and visors. This was a real experience for many, and was an incredible help in assessing this helmet and its shape.
By involving 16 fire services in the field trial, working with them, we've now had contact with more than 60 firefighters who have actually carried out these exercises, and this has provided a huge amount of feedback and is really something special. A field trial is always about finding things to improve. It's not just a tick box exercise to say we've tested it and it works, but that there is actually something we can learn from it. Which other details can we fine-tune, and which other details can we improve? To turn this from a satisfactory product into an excellent product, and to make sure that firefighters aren't acting as beta testers afterwards.
The buckle on the chin strap is a specific element where we actually had the mechanism finished, and then in the field trial we noticed that it isn't quite right. The pressure point isn't quite right. So we actually revised it in a particular area and reworked the closure and the mechanism until it fit 100%.
Here's a nice thing, for example, the squeaking sound coming from the O-ring that we use for the face guard and eye guard on the helmet. In the field trial it was causing a squeaking sound for some customers, and we had to figure out what to do about it. So we studied the situation and weighed up the risk of what could happen if, for example, you were to apply grease as a lubricant or apply another coating, or use another material, or try an O-ring of a different size or a different preload force. Having weighed it all up, you come to the conclusion that lubricating it with grease is not such a great idea. So we chose a more or less ready-made solution using the O-ring we already had. We coated the O-ring with Teflon.
For the approval tests, we have to differentiate between the different areas of influence in the world. If we just take the three biggest, those are Europe, North America, and the Australian Pacific region. As told, we are talking about 120, 150 different tests. They start with flame tests, shock absorption tests, mechanical stress tests, long-term tests, wash tests, cycle tests, chemical resistance, protective functions, and these are all just what are prescribed as tests in the standards. But Dräger doesn't stop there. We want to make sure that our helmets don't just meet the minimum requirements set by international standards, but that they are also compliant with our own demands and Dräger quality standards. Whether doing sports or playing a musical instrument, the same rules apply. If I don't exercise, I won't progress, and I won't achieve the goals I have set myself. And of course, teamwork is also important when you're playing in an orchestra, listening to one another, making music together. Perhaps there's someone taking the lead and directing everyone, taking everyone down the right path, the intended route. And this is all identical and transferable to the world of work and what we want to achieve at work.
I see a lot of similarity between the craftsmanship involved in my carpentry hobby and what we do professionally. In both cases, it's about choosing the right materials, thinking about how to work with them, which tools you are going to need, and what the ultimate aim is, paying attention to the proportions and how the pieces all fit together.
So, what do I do in my free time in nature? I think that what is so special is how everything there is so perfect, everything there is in harmony, and it is so much quieter. It's an opportunity for some quiet reflection and for me to just go with the flow. Quite the opposite of my working life, where everything is always so quick-moving, so very fast, where sometimes things happen at very short notice and you have to be in a permanent dialogue with people to be able to do what you need to do.
So yes, the final activities leading up to the launch make for a very interesting experience because they also show how we can commercialize the product later on. And this is always an incredibly exciting time, particularly when the helmet is available on the market for the first time, along with all the communication media that go with it, that we then send out online and offline to the world.
The ideal helmet is one that protects me against all hazards without bothering me or getting in my way, and even helps me with features such as integrated communication and light. I am convinced that we have met these requirements with the SafeGuard.